Hello everyone. In this session, I will be discussing one of the most important concepts in control system engineering, that is steady state error. Let us define steady state error first. The steady state error is the value of error signal when t tends to infinity. Now what is the importance of steady state error? The steady state error is a measure of system accuracy. By checking the value of steady state error, we can predict the system accuracy. Similarly, steady state error arises from the nature of inputs, then type of system and non-linearities of the system components. These are the main reasons for steady state error. Moreover, the steady state performance of a stable control system is judged by its steady state error to step, ramp and parabolic inputs. Now let's derive an expression for steady state error. You have to consider a closed loop control system shown below. We have input R of S and C of S is the output or a response. Then E of S is known as error signal and C of S times H of S is known as feedback signal. Now by looking at the diagram, we can write one expression for error signal E of S, that is equal to R of S, that is equal to R of S minus C of S into H of S, R of S minus C of S into H of S. Why? Because this is a summing point. One input is R of S, another input is C of S into H of S. Definitely we can write the output E of S, that is the difference between R of S and C of S into H of S. Please do call the expression for error signal E of S, that is equal to 1. Likewise, we can write the output signal, that is C of S, that is equal to E of S into G of S. Please do call this one as equation number 2. Right now, you need to substitute equation number 2 in equation number 1, so that equation number 1 can be modified as E of S equal to R of S minus E of S into G of S into H of S. Similarly, you can move the RHS term, that is equal to E of S into G of S into H of S towards LHS side. Therefore, LHS can be modified as E of S plus E of S, G of S, H of S, and RHS will be R of S. Now E of S can be taken as a common term. So E of S into 1 plus G of S into H of S, that is equal to R of S. From this you can calculate E of S. So E of S equal to R of S divided by 1 plus G of S into H of S. So this is the expression for error signal. As you can observe, the error signal E of S, that is in terms of S domain. You need to convert S domain into time domain to take the Laplace transform. By taking the Laplace transform, you can convert S domain into time domain. So you need to calculate E of t. So you can calculate E of t from E of S. That is, E of t is given by L inverse of E of S. Then you will be getting E of t. That means error signal in terms of time. Now E of t can be written as L inverse of E of S. You can substitute the value of E of S over here. Therefore, L inverse of R of S divided by 1 plus G of S into H of S. In general, we call the expression for steady state error, that is actually ESS. So, the steady state error is defined as the value of E of t when t tends to infinity. Now, you can directly apply the definition. Therefore, steady state error ESS is given by limit t tends to infinity E of t. So this is one expression for steady state error. Let's modify the equation. Let us see how we can modify. You can apply the final value theorem of Laplace transform. According to final value theorem, f of s is given by L of f of t. Then we can write limit t tends to infinity f of t is given by limit s tends to 0 s into f of s. Therefore, you can directly substitute the equation. That means ESS is given by limit t tends to infinity E of t or limit s tends to 0 s into E of s. Therefore, you know the value of E of s. What is the value of E of s? R of s divided by 1 plus G of s into H of s. Same value can be substituted over here. Therefore, steady state error ESS is given by limit s tends to 0 s into R of s divided by 1 plus G of s into H of s. So this is the expression for steady state error. This is one of the most important topic in control system. I have referred the textbook of control system written by A. Anand Kumar. Thank you for watching this video.